My dear students, now I am going to teach you the third part of the first chapter of 10th class, set theory. This is a very important part from the examination point of view. There are 3 or 4 or 5 topics in this part, but all the topics or all the parts of this, subparts of this part are very important from examination point of view. You should take it very carefully, and I think you will listen to me very carefully in this section. Now I am taking one by one. First, union of sets. Union of two sets is the union of all the elements or the sum of all the elements in A and B should, and repeated elements we have to neglect. Here you say A is 1, 2, 3, 4 and B is in B elements are 3, 4, 5, 6. These 3, 4, these two elements are common in these two elements, these two sets. Now if you find out the union of A and B, you have to take all the elements of A, 1, 2, 3, 4, and elements of B, which are already written in A union B, we have to left. 3, 4 already are in A, so we have to leave these two elements 3, 4 and write down 5, 6. Yani it means element should be written once. You have to take all the elements of A and B but once. Not there should be repetition, because I have told you in set theory first part the definition of set, the elements should not be repeated. So therefore in union elements should not be repeated. First take all the elements of A, then write down the elements of B which are not in A. So A union B is equal to 1, 2, 3, 4, 5, 6. This is a Venn diagram. This is a universal set. This is a set. This is a B set. All the elements A and B, all the elements of A and B, and this is the common portion, but this common portion also once. So shaded portion is A union B. This you can show the union A with the help of Venn diagram. There are two sets A and B. With the help of Venn diagram, A union B is the shaded portion in this figure. Now take second, intersection of set. This is also very important. There are two sets A 1, 2, 3, 4, 5, 1, 2, 3, 4, B 3, 4, 5, 6. But there are two elements 3, 4 in A and 3, 4 in B. These two elements should be in intersection. In intersection, we have to take common element. Listen to me very carefully. In union, we have to take all the elements of A and B but once. But in intersection, we have to take common elements of A and B, and we have to leave all other elements. So with the help of example, you have seen A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6. These two elements 3, 4 are in intersection A and B with the help of shaded portion. This is a set A, this is a set B, and these are the common elements. These are the common elements in shaded portion, and this shaded portion shows that A intersection B is this. So with the help of shaded portion as well as with the help of examples, I have made it clear to you that how will you find out A union B and how will you find out A intersection B. Next, difference of sets. Difference of set. Difference of sets. Yani you can say in the other words minus. You have seen A union B, you have seen A intersection B, now A minus B and B minus A in difference. Now A is a set 1, 2, 3, 4, and B is another set 3, 4, 5, 6. A minus B is equal to 1, 2. In difference, if you want to find out A minus B, you have to neglect the common elements 3, 4 in A and 3, 4 in B. You have to neglect these two elements. You have to leave these two elements. And in A minus B, you have to take elements of A 1, 2. And in B minus A, you have to take 5 and 6. This B minus A, 5 and 6. I think you have understood. Finding out the difference of A and B, you have to neglect the common elements. In A minus B, write down the element of A. In B minus A, write down the element of B. So Venn diagram. With the help of Venn diagram, this shaded portion minus A minus B. In the shaded portion, you can see these are the common elements we have left, and these are the elements of B in the right hand side. We also have left these elements. We have taken only the elements of A minus B. In A minus B, elements of A without common elements. In B minus A, this portion. Leave the element of A, leave the common element, and you have to take all the elements of B. That is, the B shaded portion is B minus A. So, with the help of these examples, these two examples, this is the numerical example and this is the Venn diagram example. So it is clear to you. If you have sets A, if you want to find out A minus B, then 1, 2 is the element of A minus B. If you want to find out B minus A, the elements of B minus A will be 5 and 6. We have neglected the common elements of A and B. Then what is left in A? is in A minus B, what is left in B is B minus A. In Venn diagram, it can be shown like this. This is A minus B and this is B minus A. So this is the difference of two sets. In this way, you can find out the difference of two sets A and B. Now take next. Next, complement of sets. Complement of sets. Of set. With the help of an example, I will try to make it clear. Now A is equal to 1, 2, 3, 4, and U is the universal set. 1, 2, 3, 4, 5, 6, 7, 8. This is a universal set. U is a universal set and A is a small set 1, 2, 3, 4, 5. If you want to find out A complement, you have to write down all the elements of U other than A. 1, 2, 3, 4. You have to leave these four elements 1, 2, 3, 4 and write down 5, 6, 7, 8 in the complement. So this is the example of complement set. In complement set, you will have a universal set, then one set is given to you and you have to find out the complement of that set. So the complement of that set is the elements will be written in complement which are not in A but in U. I am taking one example. U 1, 2, 3, 4, 5. U is a set of all natural numbers. U is a set of all natural numbers and A is a set of all odd numbers. And what will be the complement of A is the set of even numbers, even natural numbers. Yes, you see here in U all the natural numbers, and all the natural numbers are the combination of odd numbers and even numbers. In A, odd numbers are given. So in complement will be the even numbers, because if you find out the complement of A, you have to leave these numbers, any odd numbers you have to leave, and you have to take other than these odds, these are the even numbers. So this is the complement of A. When U is given and one set is given, you have to find out the complement of that set, neglect all the, leave all the elements of A and write down in complement all the remaining element of U. This is the complement of A in U. With the help of Venn diagram, U, this is A and these are the shaded portion is the complement of A. Shaded portion is the complement of A. This is the shaded portion. Shaded portion is the complement of A. That is A complement. A complement. So from U, you have to minus all the elements of A. The remaining elements of U will be in complement A. This is the definition. I think it will be very clear to you from both the examples. Complement of sets. Now, next 5. Disjoint sets. Disjoint set. Disjoint sets. Disjoint sets. First of all, I want to define disjoint sets. If all the elements of A are not the element of B, and all the elements of B are not the element of A, then A and B both are disjoint set. In other words, you can take it as if if the elements of A and elements of B are different, so A and B are disjoint set. With the help of example, I will try to make it clear. A is equal to 1, 2, 3, 4 and B is equal to 5, 6, 7, 8. Here you see all the elements of A and B are different. A contains 1, 2, 3, 4, B contains 5, 6, 7, 8. No element is common in both the elements, both these sets. No element is similar in both these sets. So A and B are disjoint set. Or in other word, you can say, because you have understood the definition of intersection. If you find out the intersection of these two sets, disjoint sets means that will be phi. A intersection B will be phi. Because intersection there is no common element. As I have discussed with you, in intersection you have to take common element, but here there is no common element. So therefore A intersection B is equal to phi. In other words, disjoint set. In disjoint set, intersection of these two sets is 5. If intersection is 5, then two sets are disjoint. With the help of Venn diagram. In Venn diagram, with the help of Venn diagram, I will try to make it clear. This is A set. This is a B set. A. This is a B. Both A and B are both A and B from this figure have no common element, because A is very far from B and B is very far from A, and there is no intersection here. So there is no question of common element. So these two sets, A is here, B is here, and these two sets have no common element. So these A and B sets are disjoint set with the help of the Venn diagram. Now next, De Morgan's law. 6. De Morgan's law. De Morgan's law. First, A union B complement of A union B is equal to A complement intersection B complement. Second law, A intersection B complement is equal to A complement union B complement, opposite to each other. Union, complement of union becomes the intersection, and complement of intersection will be union of different complement of two sets. So A union B complement is equal to A complement intersection B complement. A intersection B complement is equal to A complement union B complement, because you have already understood the definition of complement. So the Morgan's law defines these two rules, and these can be applicable in the different examples, and it will be discussed later on in the next part. Thank you.